All right, ladies and gentlemen, so we're moving on to some other quadrilaterals, and specifically these quadrilaterals are not parallelograms, okay? So we talked about the three types of parallelograms: squares, rectangles, and rhombi, and moving on to some two types of quadrilaterals that are not parallelograms. So first type is a trapezoid. So you can see an example of a trapezoid right here, and the thing about the sides of a trapezoid is that you have one pair of parallel sides. Okay, just one pair. The other two sides are not parallel. So we can put little parallel marks right here and right here. Now that's about all about sides. With angles, okay, there's only really one thing you know about angles, okay, and that is that same side interior angles are congruent. Okay, but this is not applicable to all sides. So it's only going to be the two sides that are not parallel. So not congruent, my fault, supplementary. Same side interior angles are supplementary, meaning they add up to 180. So this side, or this angle, and this angle are going to be supplementary. They're going to add up to 180. And then also, this angle and this angle are supplementary, okay? But you cannot say that these two are supplementary and that these two are supplementary. That's not true, all right? It's only the two on either side. All right, so these two are supplementary and these two are supplementary. But you can't do the top two and the bottom two and say those are supplementary. Okay, so that's all for the angles, really. The diagonals, okay, we don't really do anything with a regular trapezoid with diagonals. So there's nothing really to put there. There's nothing we really can tell or know about diagonals or a regular trapezoid. But that's going to change when we talk about isosceles trapezoids. So when we talk about isosceles trapezoids, some of these same things are going to apply also. Okay, so we still have, with the sides, we still have one pair of parallel. That is not how you spell parallel. Okay, so we still have one side that's parallel. Right? But we also know that our legs are congruent. Okay, so let's add a little 2 in here. So this and this are the same with an isosceles trapezoid. Okay, so think of isosceles triangle, two sides are the same. Same thing with isosceles trapezoid. It's like an isosceles triangle, except you cut the tip off of it. You cut the very top off of the pyramid or whatever. You just have the base that's left over. So that's one thing we know, is that the legs are congruent. Now with the angles, you know that your base angles are congruent. Okay, so if these are our parallel lines, we know that these two base angles are congruent, and also the top two base angles are congruent to each other. We don't know that opposite angles are congruent or anything like that. We do know that the top two are congruent and the bottom two are going to be congruent to each other. All right, now as far as diagonals go, we know that our diagonals are congruent. Okay, so this length is going to be the same as this one. And essentially that's all we really know, is that the two diagonals are going to be the same length. We don't know that they bisect each other. You can tell that one piece is a lot longer than the shorter piece. But we do know that they're congruent. And also, the piece down here is equal, and the shorter piece up here is equal to its the other side also. Okay, so but we don't know that it bisects each other at all. All right. So that's all for trapezoids. For kites, okay, so a new shape. You think about flying a kite. So whenever you fly a kite, usually resembles something like this. Okay, so the thing we know about a kite is you have two pairs of congruent sides. Okay, your top two sides are congruent and your bottom two sides are congruent to each other. Alright, so the left and right aren't congruent or anything like that. Your top two and your bottom two are going to be congruent. Alright, with the angles, we know that the left angle and the right angle are congruent. Okay, so these two angles that are opposite each other are congruent. The other opposite angles, though, are not congruent. We don't know necessarily that this is congruent to that. Okay, so we can't say that, but we can say that the left and right angles are congruent. Right, and as far as the diagonals go, we know a couple things about the diagonals. One, the diagonals are perpendicular. So right here, this makes a 90-degree angle all the way around. We have four 90-degree angles. Right, and we also know that the one is bisected. Okay, so we know that one of the diagonals is getting bisected, not both of them. So it's pretty obvious to see right here which one. This longer one is obviously not being bisected. The shorter one is in this situation. It doesn't have to be the short one, but in this situation, that's the one being bisected. All right, so that's all we know about kites. So let's go ahead and practice some problems using these properties with these new shapes, these new quadrilaterals. Okay, so let's do this one with the trapezoid right here first. So they want us to know angle R. We know S is 65. Well, we know this line is parallel to this line. So remember the side angles, they have to add up to be 180. So just do 180 minus 65, and that's going to leave 115. So angle R must be 115 because those two angles have to add up to 180. Okay, now in this one, we have an isosceles trapezoid. Alright, so on this isosceles trapezoid, you can tell it's isosceles because you've got the two tick marks. Okay, we're told that those sides are the same. Alright, so an isosceles trapezoid is the only type that you can find all the angles if you're given one angle. So on this one, I'm given one angle. I can find these other three. Over here on the first problem, I can't find angle Q and angle P just by knowing that this one's 65. There's no way to figure that out. But on isosceles, I can figure out all three of the other angles, which is what they want me to do. They want me to know what's angle V, X, and W. Okay, so we can do that because we know that the angles are base angles got to be congruent. So this angle over here, V, has to be 70 degrees. Okay, and then we also know that same side interior angles got to add up to be 180. So what's 180 minus 70? 110. So this angle is 110. It's angle X, 110 degrees. And then again, it's a base angle with angle W. Those are base angles, so W is also 110 degrees. Okay, so I'm going to go ahead and pause it and let you guys try the next two problems. All right, so on this trapezoid here on the left, trapezoid CDEF, we're given 60 degrees, and we're also told that it's an isosceles trapezoid. We got our two tick marks, and we're also given that CD is 15 centimeters. We want us to find angle FED and what is the segment EF. So I'm looking at this and I say, okay, it's isosceles. So what does that tell me? That tells me that the angles are base angles, which are congruent. So if angle C is 60, angle F must be 60 degrees also. So I make that one 60. And then I say, okay, well, how can I find the other angles? Well, I know same side interior angles are going to be supplemental, so they must add up to 180. So if angle C is 60, I take 60 away from 180, and that leaves 120. So angle D must be 120. And then similarly, angle D and angle E are both base angles of the isosceles trapezoid, so they must be congruent. So angle E is also 120. Then if I know CD is 15, I want to find EF. Well, those tick marks indicate those sides are congruent, so EF is also 15 centimeters. So that's where I would get all those. And then on this other trapezoid, JKLM, I'm told that KM, which is a diagonal, is 22, and I'm asked to find JL, the other diagonal. Well, I know that in isosceles trapezoids, the diagonals are congruent with each other. So JL must also equal 22. So let's move on to some kite problems. All right, so the perimeter of this kite is 116, and we want to find x. Okay, well, I see these tick marks right here. This indicates that these are the same, so this is also x. 2 marks indicates that these are the same, so this one's also 28. Remember, perimeter, because I'm thinking, what is perimeter? Perimeter, okay, think of like escaping from jail. They say check the perimeter, that's the distance around. So I need to figure out what is the total all the way around this shape. So to do that, I'm going to add up all of the sides. So x plus 28 plus 28. They tell me the perimeter of the kite is 116. So all of these should add up to be 116. Now I can set up that equation and solve for x. So x plus x is 2x. 28 is 56. Now I'm going to subtract 56 from both sides. 2x equals, take away 56 from 116. That's going to leave 60. And then we divide by 2. So x must equal 30. Okay, it's not 30 degrees, it's 30. It's the side length. Okay, so x is 30. All right, now let's do this one down here below that problem. I want to find x and y. And I'll let you guys do the two on the right this time. Find x and y. Okay, so right here is my x, this angle, and right down here is y. And I want to figure out what are those values. Okay, well, one thing we know about a kite is that the diagonals are going to bisect these angles right here. So this angle and this angle are going to be the same. So this top one is x, the bottom is also x. All right, so now once this is x, down here I have 80. I also know that the diagonals are perpendicular. So this right here must be 90 degrees. So looking at this triangle, I have two angles, 80 and 90, and I want to know what's the third angle. Well, I know 3 angles of a triangle must add up to be 180 degrees. So I'm just going to take 180 and subtract 80 and subtract 90. When I take those away from 180, I get 10 degrees. So x equals 10 degrees. Okay, so then for y, I'm given, I'll put y in the wrong spot. Let's fix that. So again, I know this one's 90, and y is this angle now. Okay, so up here this angle is 50, but the left and right angles got to be the same, right? That was one of our properties about kites, is that the angle right here and this angle right here have to be the same. So if this one's 50, this number down here is also 50. All right, so if that's 50 and this is 90, again, just take those away from 180 to figure out what y is, because those are 3 angles that make up this little triangle right here. So I do 180 minus 50 minus 90. And when I take those away, I get 40 degrees. So y equals 40 degrees. So I got x and I got y. All right, I'm going to pause it and let you guys try the other 2 problems. Go ahead and pause the video, give them a try. All right, so I'm told that this is a kite, and AB is 12 and AD is 4. So I went ahead and labeled AB with 12 and AD with 4. And they asked to find BC, DC, and the perimeter. Well, these sides that are the top 2 sides and the bottom 2 sides got to be the same. So the top 2 sides are both 4, the bottom 2 sides are both 12. And to find the perimeter, I just add all of them up. 4 plus 4 plus 12 plus 12, and I get 30. On the last problem, a little bit tougher one. Okay, FLY is a kite with FL equal to LY. So FL, they tell me, is equal to LY. And I want to find W, X, and Y. Okay, so W, if these 2 are the same, these 2 sides are the same, FL and LY, then that must mean that this side is the same as this side. So W right off the bat, I can tell is 4. Because if these 2 are the same, then that must be either the top or bottom of my kite. So whenever those are the top, that must mean that this one is the one that's getting bisected. Okay. So then the next thing I can figure out is x or y. I know that these make 90 all the way around. Okay, and then because I know that these two sides are the same, 30, okay, it's on the left, so my angle on the right has to be the same. So x must equal 30 degrees, because the left and right angles are congruent in a kite. Okay, so now real easily I can figure out what y is, because I know x is 30, and I know the right angle is 90, so I just do 180 minus 90 minus 30, and that leaves me with 60 for y. So y is 60, x is 30, and w is 4. All right, appreciate your all's attention. Go ahead and knock out some practice on kites and trapezoids.